So value-focused thinking really underpins the system decision process and the value modeling that is task 3 of the problem definition phase. But how do we actually accomplish value-focused thinking? One of the key ways we do that is with value modeling, which we break up into qualitative and quantitative value modeling. What we'll be talking about today is mainly on the qualitative side. So qualitatively, what we want to do, what we want to accomplish is build what we call a value hierarchy. And as you can see on the left-hand side of your screen, if we're talking about the rocket and delivering a rocket payload, we have a fundamental objective and followed by nested functions in that verb object form, then objectives and value measures. And I'll go into more depth on these, but essentially, we want to spell out what our system needs to accomplish at a high level. That's our fundamental objective. Then we have our functions that support the fundamental objective. In this case, launch the rocket, transport the payload, and achieve the desired effects. And nested below that, we have our objectives and our value measures. So our objectives are what we're hoping to do, either in a maximize or minimize statement. It's a statement of preference. And then our value measures are our metrics, or how we can actually measure our statement of preference, and we always make sure we tie a unit to our value measure. So as you can see here, this value hierarchy, it provides a complete description of the stakeholder values all the way down from the fundamental objective up top, delivering the payload rapidly and accurately, down to our specific value measures, such as how many operators we need, how much thrust is the rocket producing, etc. So we start at a high level, and then we continue to get more and more detailed until we are able to map to specific metrics that are measurable and that we will apply when we're looking at different alternatives we consider. On the quantitative side, we're going to talk about a couple key ideas. All right, the first thing is this idea of value functions. So in a value function, what we want to do is we want to essentially build a scale and convert all of our different and our varying value measures from the different units they're in, all to a value currency. We want to speak in one language, and that language is going to be value. All right, so you can see on the left we have a whole bunch of value measures with all different units associated, everything from kilometers to meters to kilograms to number of operators to number of different payloads. Those are all different value measures that we have in different units, but when we convert them, we'll use our value functions to convert all of those different units into value currency, if you will. We'll get a value score. And that value score will be between 0 and 100 for the sake of SE301. All right, what we also need to do is we will build what we call, one example here, we'll either use swing weight matrix or a pairwise comparison. We'll talk about both of those in today's class in a little bit. But we need to assign weights to our value measures, because while we have 7 different value measures, they are not all equally weighted, right? So some may be more important than others, some may have greater variation than others, and we want to assign a number, a weight, between for each of those 7 value measures that reflect how the stakeholder actually feels. All right, and then we put it all together using this equation at the bottom. The V of xj equals the summation from I equals 1 to n for a given weight times a value score for that alternative. All right, so essentially what we're saying there is we will add up the weighted score for each alternative that we're considering for each value measure. So in our example here, we have 7 value measures. We would essentially have 7 terms, and each term would include a weight and a value score, right? So we multiply the weight times the value score for a given alternative, and we do that for all 7 value measures. We'd sum it up, and that is our total value score for a given alternative. And as it says below, we'll use the value functions and the weights and that equation to eventually score or evaluate our candidate solutions. All right, but before we get into the math side of the house, we need to talk about our qualitative value model, also called a value hierarchy. So those terms are interchangeable, qualitative value model and value hierarchy. And we'll start at the top and work our way down. This is one of those slides I would make sure I am familiar with and all the terminology and how we can build these out. All right, so if we start at the top, we're talking about our fundamental objective, and you can pull this. This is nested or comes directly from your functional hierarchy, which we've already talked about, and it represents the desired outcome of your system, right? What needs to occur at a very high level, the highest level for system success. All right, and this should take the form of verb object, but you may put some additional modifiers or descriptions in there as necessary. Now, below our fundamental objective are our functions. So our functions are the tasks, actions, or activities that need to occur to support the fundamental objectives. Okay, and they need to take that verb object form. Very important that we continue on with verb object when talking about functions. Our objectives are statements of preference, and when we talk about objectives, we want to say they will either maximize, minimize, or optimize. All right, so typically we'd like to try to use maximize or minimize, because using optimize can be a bit of a challenge, right? To optimize, you have to have a very specific value you're trying to achieve. Whereas if you say maximize or minimize, you can just say less is better or more is better type situation. And then finally, nested and directly tied to each objective is a value measure. Our value measures, when they come from our stakeholder values. And when we talk about a value measure, we need to make sure that we have we need to associate a unit of measure with them, and then either more is better or less is better. Okay, so when we're talking about that, in our previous example, we saw different types of great variety of units, right? We saw everything from kilograms to kilometers to number of payloads, etc. Those are all different units, right? It could be anything from a weight to a speed to number of seatbelts in a car, and those are all valid units of measure. And then we want to make sure we add whether or not we want to have it increasing or decreasing, MIB or LIB. More is better or less is better. Now, when we talk about value measures, we can put them in 4 different buckets, okay? So we have 2 types of value measures and then 2 scales for value measures. Our types of value measures, if we're talking first, our first type would be a direct value measure. So our direct value measure is just as it says, you're directly measuring an objective. So some examples of that would be if you're talking about speed and you want to maximize speed, you could use a value measure like miles per hour. That would be a direct measure of speed. If you're talking about weight, pounds or kilograms, directly measures weight. Now, there's sometimes where your objective might be to maximize safety, but you can't necessarily measure safety as an example. So you do use what's called a proxy value measure. And that's measuring the attainment of an associated objective. All right, so if we're talking in our car example, a proxy measure for safety could be number of seatbelts potentially, or maybe number of fatalities for a car over a year, right? For a certain car model, what is the number of fatalities per 100,000 miles driven, something along those lines. All right, that's a proxy measure. It implies there's some association with safety, but it's not necessarily measuring safety directly. So we'd call that a proxy measure. All right, and then we have 2 different scales where we can consider our value measures. A natural scale is something that's naturally occurring. It's that simple. So again, our miles per hour is a natural measure of speed. We're not doing any math or any kind of derivatives or integration, differentiation, anything like that, right? We can measure it in nature. It's a natural measure. Same goes for weight and pounds for weight. Now on a constructed scale, this is something many of you are familiar with. If we're talking about safety, star rating scales often are used to measure safety. Think front collision ratings, side collision or airbag ratings, etc. If we're talking about restaurant cleanliness, there could be OSHA health ratings for health or cleanliness of a restaurant. I'm sure you all are familiar with Yelp and, is it 4 stars, is it 5 stars, etc. That is a constructed scale, right? It's not naturally occurring. It's crowdsourced and it's a constructed 1 to 5. There's no reason it couldn't be 1 to 7 if Yelp wanted to change it to 1 to 7. So that's another constructed scale that you'll often see. Now, you'll notice there is a $ with a line through it, right? We're saying do not use money, do not use cost as a value measure. I understand that cost is important, and systems engineers actually understand that cost is extremely important. Cost, in fact, is so important that we will do we have a whole separate task for cost. We call it cost analysis that occurs later in the SDP. And ultimately, we will compare the value versus the cost and see how much bang for our buck we're getting, right? So we will put value on its own scale, and we will put cost on its own scale, and consider cost separate from value. But we can only do that if we do not include cost as a value measure in any way, shape, or form. Otherwise, we kind of start double counting, and we will begin to conflate our value modeling. So do not include cost as a value measure. It will become more clear to you as we continue through with the SDP process. A couple notes as you see at the bottom. So value measures need to be directly aligned with their objectives. And they tell us, what they're telling us is how well we actually attain an objective. So an objective is a statement of preference. However, the value measure is how we measure, how we quantify how well we're meeting that statement of preference. All right, and when we're talking about preferences for value measures, we have our different types, right? So we can have any of the 4 listed here. We could have a direct natural value measure, we could have a proxy constructed value measure, and anywhere in between. So there's 4 types of value measures. You can have direct natural, direct constructed, proxy natural, proxy constructed. Ideally, we would have all direct natural because it's the easiest to measure. It's occurring naturally. There's no additional analysis or calculations or filters essentially put onto it, right? Versus if we're using a proxy constructed scale, we're getting further and further from ground truth the more layers or detail we kind of add on to our value measures. So this would be a way to think about if we had to rank our different types of value measures. We always seek direct natural, that's most preferred, and constructed proxy are least preferred.